In this video, I want to give you an introduction to polynomials. And this video is going to be pretty heavy with vocabulary because there are a lot of new words associated with polynomials, and you've got to be able to talk the talk to communicate effectively. Alright, so in a previous video we talked about monomials. And remember, a monomial is a number, a variable, or the product of numbers and variables, where the variables have only whole number exponents. Okay, so you'll see this first expression, 5x cubed y squared. This is a monomial that has the coefficient of 5, and we're multiplying variables x and y together, and their exponents are 3 and 2, which are both whole numbers. Another word that we have is a binomial, and much like monomial, binomial means two. Again, that prefix bi, like a bicycle has two wheels. And so what this is we actually have two monomials, and we're either adding them or subtracting them. Okay, so we can say two terms. We have 5x, and that's a monomial, and we have 3y squared, that's a monomial, and we're just subtracting those two. And lastly on this, we have a trinomial, and again, like tricycle has three wheels. This trinomial will have three monomials that are being added or subtracted together. Okay, so in general, a monomial, a binomial, and a trinomial are all polynomials, but they're special polynomials because of the number of terms they have. The monomial has one term, a binomial has two terms, and a trinomial has three terms. And the next thing to talk about is the degree of a monomial, and that's going to be a quick review as well. So let's go ahead and look at negative 9x cubed y to the fifth, and also 1/2 a cubed b. So remember, when you're finding the degree of a monomial, it's going to be the sum of the variable exponents. So x and y each have exponents, and they are 3 and 5. So the degree of this monomial is 8. Likewise, the variables here, a and b, have exponents of 3 and 1, respectively. So 3 plus 1 is 4. So this is degree 4. So we're going to use this idea to go ahead and find the degree of a polynomial as well. So let's go ahead and write a polynomial here. So we have 4x squared plus 5x cubed minus 2x plus x to the fourth minus 7. So lots of terms here. In fact, how many? Well, 4x squared, and we have 5x cubed, a negative 2x, an x to the fourth, and a negative 7. So 1, 2, 3, 4, 5 terms. And we know there are 5 terms because when we count the number of addition and subtraction signs, there will always be one more term than addition and subtraction signs. So 1, 2, 3, 4 signs and 5 terms. Okay, so the degree of a polynomial is going to be the degree of the highest degree term. So we have 5 terms. The degree of this one is 2. We have x squared. The degree of this one is 3 because x cubed. The degree here is 1 because it's x to the first. Remember, when the exponent is not written explicitly, it's understood to be a 1. The degree here is 4 because x to the fourth. And negative 7 is a constant, so its degree is 0. Okay, so we have all the degrees. Let's see, 0, 1, 2, 3, and 4. So the highest degree term is a 4. So the degree of this polynomial then is 4. So once again, the degree of a polynomial is going to be the degree of its highest degree term. So with polynomials, each degree has its own name associated with it. So instead of saying degree 2 or degree 4 all the time, we actually have words that go along with them. So let's go ahead and look at a quick table of all of these words, and then we'll kind of talk through them and classify some polynomials. You may want to go back to that slide right there and copy those down for future reference, or go ahead and memorize them. They're not too bad to memorize because of the prefixes. So let's go ahead and classify some polynomials, and we'll do so based on the number of terms that they have and also their degree. So let's start out with 7x squared minus 11. Okay, so we have two terms, so we know this is going to be a binomial. We have 7x squared, and this is degree 2. And we have a negative 11, which is a constant, and that's degree 0. Okay, so what's the degree of this polynomial? Well, it's 2. And how many terms does it have? Well, there's the 2 terms. Okay, so we know the degree, we know the number of terms it has. So degree 2, what was the word associated with degree 2? Well, that was quadratic. And let's not confuse, I know quad looks like 4, but this I believe is a Greek prefix, and it's actually quadra, which means 2. So this is a quadratic binomial. Okay, and that's how we can classify that based on its degree and the number of terms that it has. Let's go ahead and take a look at a second example. So we'll do 13x to the 7th plus 5x minus 4x to the 5th. Okay, well I have one addition and one subtraction, so 2 signs, and it looks like then 3 terms. And what's the degree of each of these terms? Well, it looks like the first one, the variable exponent is 7. The second one looks like the variable exponent is 1, so degree 1. And the final one, the variable exponent is 5, so degree 5. Once again, the degree of the polynomial is the degree of the highest degree term. So we have a 7 here, and that's larger than 1 and 5. So degree 7, and the word we use with degree 7 is septic. And there are 1, 2, 3 terms, so we're going to call that a septic trinomial. Okay, and let's do one last one here as far as the classification here is concerned. We have 8n to the 10th. Looks like just a single term, so this is going to be a monomial, and it looks like its degree is 10, right? So 10 is going to be called decic, and so it's a decic monomial. Okay, one more thing that I want to talk about a little bit, and we'll use this polynomial here as an example. So each term can be named by its degree instead of just saying this is the degree 7 term, this is the degree 1 term, and this is the degree 5 term. We can say this is the septic term, this is the linear term, degree 1, and this is the quintic term, degree 5. So in that way, we can name terms one at a time by their classification, septic, decic, and so forth. Okay, moving on, almost done here. Let's talk about the standard form for a polynomial. So standard form for a polynomial will be when your polynomial is written in such a way where the degree of each term is in decreasing order. Okay, so from highest to lowest. And let's go ahead and maybe revisit this one right here. So we had 13x to the 7th plus 5x minus 4x to the 5th. And we said the degrees were 7, 1, and 5. So you'll notice these degrees are not written in any particular order, 7, 1, and 5. But what's the biggest one? Well, 7 is the largest one, so let's start with that degree 7 term, or that septic term. And the next largest is a 5, so let's follow it up with our quintic term. And the negative, the subtraction sign that's out here, goes with the term. So we'll always keep the sign in front of the term. So negative 4x to the 5th. And finally, then, degree 1 is the last one, so our linear term. So we'll say plus 5x. So now this is written in standard form. And then the last piece we want to talk about is what we call the leading coefficient. And the leading coefficient is going to be the coefficient of the highest degree term. For any polynomial written in standard form, it will always be the coefficient out front. Okay? In this case, that's 13. So let's do one more example. So let's say we have something like maybe 7x cubed plus 10x plus 3x squared minus 8 plus x to the 4th. Okay? So we see we have a lot of terms, a lot of different degrees. So let's go ahead and take a look at each one. And how many addition and subtraction signs do we have? 1, 2, 3, 4. So that means we have 5 terms. 1, 2, 3, 4, 5, which we do. So this first one is degree 3, so that's our cubic term. The second one is degree 1, so that's our linear term. The third one is degree 2, so that's our quadratic term. The fourth one is degree 0, so that's our constant. And the last one here is degree 4, so that's our quartic term. So we can go ahead and write this in standard form, and then we'll also address the leading coefficient. So the largest one here looks like degree 4, so we'll put our quartic term first. And the coefficient here looks like just positive 1, but since we're doing it at the front, we don't need to write that plus sign. So that one's done. So 3 is the next highest. And notice that this guy doesn't have a negative, which means he's positive, and that's why I'll put a plus right there. So 7x cubed is our cubic term. Next biggest is a 2, so our quadratic term. And next biggest is a 1, so our linear term. And finally, our constant of negative 8. Okay, so this is now written in standard form. And the leading coefficient is the coefficient of this highest degree term. Well, there isn't a number right there, so remember, when there's not a number, it's understood to be a 1. So the leading coefficient of this polynomial is 1. Okay, so we have just seen how you can find the degree of a monomial and find the degree of a polynomial, and we can also classify polynomials based on their degree and number of terms, and we can write polynomials in standard form and identify their leading coefficient.